Today we will derive these 1, 2, 3, 4, 5, 6 equations. How? Very easy, very simple. We start by cosine 2 theta. Cosine 2 theta equal cosine theta plus theta. This equals cosine theta multiplied by cosine theta minus sine theta multiplied by sine theta. We have here cosine theta squared minus sine theta squared. We prove this equation, hence we should prove the other equation, which is we just substitute for cosine squared theta. Why? We just want sines in the equation. This will give us 1 minus 2 sine theta squared. Then we want to substitute for sine squared theta. Cosine. We just want cosine only. After that, we have 2 cosine squared theta minus 1. This equation, this trigonometric identity. We have this trigonometric identity. Then we have the other identity, sine 2 theta. Just pretty easy, pretty simple. Sine 2 theta equals sine theta plus theta equals sine theta cosine theta plus sine theta cosine theta equals 2 sine theta cosine theta. So now we have the other equation, tan 2 theta. First of all, we have to solve for tan a plus b. We know that tan a plus b equal tan a plus tan b divided by 1 tan a tan b. But how? Very easy, very simple. We know that tan a plus b equals sine a plus b over cosine a plus b. This sine a cosine b minimized. Cosine a sine b, and here cosine a cosine b sine minus sine a sine b. So we should divide every term by cosine a cosine b. Let's do that. So we divided every term by cosine A, cosine B. So that cosine B with cosine B, and there here, cosine A with cosine A, that cosine A, cosine B with cosine A, cosine B, and here we have, what we have, tan A plus B. Sine A over cosine A equal tan A plus tan B, all divided, this is 1 minus tan A tan B. So we have proved this formula. Now let's prove tan 2A. We know that tan 2A equal tan A plus A. So that equal tan A plus tan A over 1 minus tan A multiplied by tan A. So here we have 2 tan A over 1 minus tan squared A. So we have proved this formula. Yeah. Now let's prove those 3. So from this formula that we have already proved, we just rewrite the formula as theta, when the other side it is half theta. It's the same formula. Then we solve for cosine half theta. So we add 1 in the other side and divide by 2, and that's equal to cosine half theta. And now we multiply by the conjugate. I'm sorry, don't multiply by the conjugate. That's the finest form. And we know the other formula, where this equals to 1 minus 2 sine squared of theta. So we just reduce, reduce this half angle formula to make it a half angle formula. And now we solve for sine. Oh, I forgot here. No, I'm sorry. So here's squared, don't forget. And now we reduce again, divide by -2, and that equal to 1 minus cosine theta over 2. That's right. So sine squared half theta equal 1 minus cosine theta over 2. So now I have to find tan squared half theta. That's very easy, very simple. We just take this, which is equal to sine squared of half theta. We take 1 minus cosine theta over 2 and divide it by cosine squared half theta, which is cosine theta plus 1 over 2. 2 goes with 2. Tan squared half of theta equal 1 minus cosine theta over cosine theta plus cosine theta, then plus 1. We multiply then by the conjugate. By what? The conjugate. We get 1 minus cosine 2 squared theta over cosine theta plus 1 squared. Then we get sine theta over cosine. This is a useless. It is just like that. That use this. This is simpler. Okay. So we end the video for today for proving all these formulas. See you tomorrow.